Hi, welcome to today's video. Today's video I'm going to be exploring just the concept of polarity in bonds. So it's not going to be a long video, but the thing you need to understand out of this one is to have an understanding of what electronegativity is, because that will help you to determine the polarity in a bond. So electronegativity is the ability of an atom to attract electron density to itself in a bond. So not every atom can attract electrons to itself in the same way. Okay, we know that metals like to lose electrons. Okay, they want to give them away. So that's a good indication that metals have a really low electronegativity. They don't want to attract them in, they want to get rid of them so that they've then got a full outer shell underneath. Non-metals, on the other hand, they want to fill up their shell to get 8 electrons. So that means non-metals are really good at attracting electrons. So they have higher electronegativity. Fluorine is the most electronegative atom. So if you just remember everything goes towards fluorine on the periodic table, that'll give you a really good understanding. Alright, so I'm going to show you about what we mean by polarity in a bond. Okay, so if we look at, let's say we have a bond between a carbon and we have a hydrogen. So just a normal bond like this. Okay, this is part of a larger molecule. Alright, this obviously doesn't exist by itself, but we're just looking and focusing on one individual bond at the moment. If you think about a bond, that one line actually is represented by 2 electrons. Okay, so we've got 2 electrons here. That's what a bond is. Those 2 atoms overlap their outer shells and they create a bond. Now, within those 2 electrons, we've got to think about what's happening for each of these atoms. A hydrogen over here, in its nucleus, has 1 proton. Whereas a carbon over here, in its nucleus, it's got atomic number of 6, so it's got 6 protons. Now, hydrogen only has 1 electron shell, carbon has 2 electron shells, so obviously those outer shell electrons are a little bit further away. But 6 protons here gives a much stronger ability to be able to attract negative charges to its positive nucleus. So the carbon here, is more electronegative. And the reason it's more electronegative is because it's got more protons in its nucleus, all right? And the fact is it doesn't have a lot of extra electron shells at the moment, okay? So what that means is that this carbon here is going to be able to attract these electrons over towards itself more readily than the hydrogen will. So in a bond, okay, if we have our bond back in the middle here, the electrons wouldn't actually sit in the middle of the carbon and hydrogen atoms. They would actually be attracted over towards the carbon a little bit more. So instead of being there in the middle, they sit closer over here towards the carbon. Now, they haven't gone all the way to the carbon. They're not donated all the way over to the non-metal like they would in an ionic bond, okay? But they are closer to it. So what that means is that the carbon has a bit more of a negative charge than the hydrogen does, and we represent that with what's called dipoles. So a dipole is something that represents a partial positive or negative charge, and we represent it with a simple symbol, okay? It's the Greek symbol, okay? And to draw a partial positive charge, a delta, all right? You draw it like you're drawing an 8, so you go like this, and then you stop just before you close it, okay? So hopefully you can see that, and then you've either got a negative or a positive up the top, depending on if it's a partial negative or a partial positive charge. So because this carbon is slightly more electronegative than the hydrogen, it's going to attract those electrons to itself, and that means that that's going to have a delta negative charge and the hydrogen is going to have delta positive. So we're still going to have here a carbon to hydrogen bond, but within that carbon to hydrogen bond, the carbon's more electronegative, so that pulls more of the electrons towards itself. That means it's got a slightly negative charge, which would give the symbol delta minus, okay? I'll show you one more. Alright, got to remember that fluorine is the most electronegative, okay? And it's sometimes quite easy when you've got the periodic table to work out which one's closer to fluorine, okay? So you might have one that's maybe only 2 boxes away and you've got one that's 4 boxes away. But what happens when you've got things that are really close to fluorine? So if you look on the periodic table, here's fluorine, the most electronegative element. Then what you've got is you've got chlorine underneath it and you've got oxygen over here. Okay, so here's our periodic table. What would happen if we had a bond between an oxygen and a chlorine? So we've got an oxygen and we've got a bond to a chlorine over here. Okay, Well, which one of those will be the more electronegative out of the two? What we've got to have a look at is we've got to think about oxygen here. It has an atomic number of 8, so that's got 8 protons in its nucleus. Chlorine has an atomic number of 17, so that's got 17 protons in its nucleus. Okay. So on the surface, it looks like chlorine should be the one that's more electronegative because it's got double the number of positives in the nucleus. However, what you've also got to remember in this case is that oxygen here has 2 electron shells, but chlorine, because it's in period 3, has 3 electron shells. Okay. So in this instance, oxygen is actually more electronegative, okay? Because the electron shells for oxygen sit closer, that outer shell, to the nucleus, it's easier for it to be able to attract those electrons. The electron shell for chlorine is further away from the nucleus, so it's a little bit harder for it to actually attract those electrons to the 17 protons. So even though it's got a stronger positive charge in the middle, the electron shells are further away, makes it harder to attract them. It's a little bit hard to get used to and to try and be able to predict off the periodic table if they're the same distance away from fluorine as to which one's going to be more electronegative. Sometimes it's good to just Google the electronegativity values. The higher the value, the more electronegative it is, and that will be the one that's the negative charge. But what's sort of a general rule, now this doesn't always fit, but you can probably sort of apply this, okay, is if you've got, okay, double, like less than, or about double the number of protons, okay, you need to have about the same number of electron shells, okay? So if you need to have a much higher ratio of protons, all right, before this comes into play for the electron shells, okay, to override that. So again, I probably didn't explain that well, sorry. So if you're looking at something which is like 2 tiles away, for example, okay, again, I will just Google the electronegativity values, or you kind of think about it, okay, does this have, if it has like triple the number of protons, that's probably going to overcome the fact that there's 1 extra electron shell, okay? But it's a bit harder to predict. So again, just Google it. So in this situation here, the electrons in this oxygen-chlorine bond would sit closer to the oxygen, and so we would have a delta negative on the oxygen and a delta positive on the chlorine. So the key is just to identify which is the most electronegative element. When you're first starting off, I would, as I said, Google them, or you can get periodic tables off the internet which have electronegativity values, and you can use that. Once you've gone through for a while and you've started to have a look at bonds and you've put in your delta negatives and delta positives for your partial charges, you start to remember which ones are more electronegative, okay? But if you're stuck, remember everything goes towards fluorine over there. This has been an introduction to polarity and bonds. I hope that you've been able to understand this. You might want to have a look at it again. The key thing is to remember everything goes towards fluorine. Fluorine is the most electronegative element, and we represent the uneven sharing of electrons in a bond with the delta negative or delta positive charges. All right? If you've got any questions, please ask them below. If you've got any suggestions for any videos that I should do, please put them below as well. Have fun, stay safe, and I'll see you in the next video. Thanks, guys.